We're ready to start checking our warm-up, reviewing what we had covered right before break. So we have rational exponents, which means we need to change these into radicals. So I have negative 8x cubed to the 4th third. So that means the 3 is going to be our radical. And it's negative 8x to the 3rd to the 4th on the inside. Again, I always recommend taking the radical part first to make them smaller. The cubed root of negative 8 would be negative 2. The cubed root of x to the 3rd, don't remember if this was part of it, but think of it. If you have 3 x's and you have the cubed root of it, well, that means you have 1, because there's 3 of them appearing one time. And then we raise that to the 4th. Negative 2 to the 4th is a positive 16. Negative 2 times negative 2 times negative 2 times negative 2. And x raised to the 4th is to the 4th. Number 2, 4 to the 3/2. So that means the square root of 4 cubed. Square root of 4 is 2. 2 cubed is 8. So there were your two answers. And again, the x cubed part might have been unknown. Maybe you figured it out. Basically, you were just looking at the fact that you had 3 of them. So in the cubed root, that means you would have 1. We are jumping all the way to Module 14. We'll be coming back to some of the other modules later on this year. So go ahead and turn to Lesson 14.1. And then unpause the video when you're all ready to move on. We're going to have a lot of interesting vocabulary in this module. The first word is polynomials, so we'll come back to that one. But the first one that we have to identify is what we call a monomial. This is important, so you might want to highlight or underline it. A monomial is a number or a variable or a product of numbers and variables that have whole number exponents. A monomial cannot have more than one term, which means a plus or minus sign, and you cannot have a variable in the denominator. So it's like one term, whether it's a single number, single variable, or numbers and variables put together by multiplication. So we have some examples of what are monomials. The number 5 by itself, the letter x by itself, negative 7xy, since that's all being multiplied, 0.5x to the 4th, that exponent's positive, so we're good there. But as soon as we have negative exponents, or plus or minus sign, which means it's more than one term, or a variable in the denominator, those are not monomials. So I want you to go ahead and, just based on the quick understanding that we did, see if you can fill out this chart on which ones are monomials and which ones are not and why. And then unpause this when you're ready to check how you did. So the first one, x cubed, yes, that is a monomial. It's one term because it's the product of x 3 different times. Square root of z, no, that's not a product. Two to the 5th, yes, because it's simply a number. Six over k squared is no, because you have a variable in the denominator. And 4x plus 7 is no, because that's 2 terms and not 1. Or you also could have said maybe there was the fact that there was an addition sign, so it wasn't just a product would be fine. But the biggest thing to recognize is if you have a plus or minus sign, that means you no longer have one term, you've got more than one. Number 1, they want to know why 16 to the 1/2 is a monomial, but x to the 1/2 is not a monomial. So go ahead, think that through, figure out how you would explain that, and then check with a partner. To the 1/2 is a monomial because you can simplify it to 4, because it's the square root of 16, which is 4, but you cannot simplify x to the 1/2. But if you do simplify it, you get the square root of x which is not a product. So here we go with a lot of our vocab here. Classifying polynomials. Well, first of all, let's think about this. Poly, hopefully you've heard of that before, actually means many. And the nomial part we're going to be thinking of as the terms. So a polynomial is either one monomial, and again, mono, meaning one, that one term, or the sum or difference of more than one monomial. So polynomial could have plus and minus signs in there, but it doesn't have to. It's kind of like an overall category. For example, if you think about shapes, quadrilateral are four-sided shapes, but you can get more specific than just quadrilateral. You could call it a square, you could call it a rectangle, but those are still classified as a quadrilateral, so it's very similar to that. So monomial is the first type of polynomial, which means one term. The second one is binomial, bi meaning two, and the last one then is the trinomial, meaning three. So a monomial would not have an addition or subtraction sign. A binomial would have one in order to separate into two, and a trinomial would have two addition or subtraction signs to separate the three terms. Not only do we classify them by the number of terms, we also classify them by the degree of a polynomial, which is the greatest sum of the exponents in each term. This part is more confusing usually to students than classifying the type of polynomial, so we'll spend a lot of time on the degree going over it in detail. They don't actually label the degrees, but we're going to go ahead and do so for a couple of them, just because we need to be familiar with some vocab. So here, the first thing it says is to classify the polynomial by degree and number of terms. Well, let's start with the number of terms. Notice that I do have a subtraction sign, so it can't be a monomial. I've got one term here and one term here. Or you could think of it as a monomial and another monomial. So that means we've got two, which is why we call it a binomial. Now the degree is each monomial put together. So for example, 6x cubed, and degrees are only with variables. I'm going to write that down. So degrees are exponents of variables. Numbers don't count towards degrees. So letter A, 6x cubed, has a degree of 3, x cubed. However, when I look at 5x squared, y squared, we actually have to add those exponents together, 2 plus 2. So this one has a degree of 4. Now to figure out what to classify it as, we take the higher number. We don't add the 3 and the 4 together because they're not in the same monomial. So since 4 is higher, we say it has a degree of 4. So this is called a fourth degree binomial. Now, fourth degree can also be called by the name quartic. If you think of 4 quarters, then that makes sense that we would call this quartic. Looking at the next one, letter B, we have 3 to the 5th plus 2n squared plus 8n. So here we have just a number. It doesn't have a variable. So since it doesn't have a variable, we say it has a degree of 0. Yes, it has an exponent of 5, but that exponent's attached to a number, and degrees only refer to exponents of variables. The second one has a degree of 2 because it has the n squared. And then the next term has an n, which has an invisible exponent of 1, so it has a degree of 1. Since we had separate terms, we look for the degree of the highest one, which is the 2, so we call it a degree of 2. Now, I've got one term here, second one here, and a third one here. So 3 terms we call a trinomial. If you have more than 3 terms, we simply call it a polynomial because there's many of them. So we only have monomial, binomial, and trinomial. Lots more for degree words, but for the number of terms, we only have 4. Again, monomial, binomial, trinomial, and then polynomial. Now, degree of 2 has a name of quadratic. Now, a lot of students get this confused with 4 because of the word quad, but remember, quartic goes to 4, quadratic goes to 2. This one is the most important degree that you need to know this year, and you do need to know the word quadratic. So it says, is x cubed y squared plus x to the 0.5 a polynomial, and justify your answer. And this is not a polynomial. .5 is not a whole number exponent. Which was part of our rules at the beginning. So in order to be a polynomial, it first has to be a monomial. So we got 4 here that we're going to work on. Let's do the first one together, and then you can do 4, 5, and 6 on your own and see how you do. So first of all, we're going to classify by the number of terms. So I've got plus or minus signs, which means it can't be a monomial. So I've got 1, 2, 3. So 3 terms means we have a trinomial. Now I have to figure out the degree. Well, the first one, 4xy squared, the x has an exponent of 1. So I need, since this is one monomial, I need to add those together. So this one has a degree of 3. The second term, we have an x squared and a y squared. So that has a degree of 4. And then the last one, each of those have an invisible exponent of 1. Add those together, so it has a degree of 2. Now remember, we only add the exponents when they're in the same term. Now that they're not in the same term, we pick the highest one, which is 4. So we call it a fourth degree trinomial. Now that is called quartic, but for this book, they're just happy with you listing the number of the degree. And yes, I know there's more degrees we need to talk about. We'll do them after these examples. So go ahead and try 4, 5, and 6, and then unpause this video when you're ready to check the answers. Definitely talk it over with a partner as needed. Number 4, there was a plus or minus sign, so it can't be a monomial. There's only one minus sign, so it's separating two terms. So this is a binomial. One term, two terms. The first one, we've got an invisible exponent of 1. Since ab squared is in the same term, we add the 1 and 2, which is 3. The next one we have a squared b, which has an invisible exponent of 1. Add those together and it has 3. They're both the highest, so this is a third degree binomial. And a third degree is also called a cubic, because a cube is a three-dimensional shape. Number 5 was also a binomial, two terms there. The first term should have had a degree of 3, 2 plus that invisible 1 exponent. The second term had a degree of 2, so the highest one here is 3, which means we probably called it a third degree. Again, just to start being familiar with vocab, it is also referred to as cubic. Number 6 was a trinomial. There were 3 separate terms there. The first one had a degree of 4, 2 plus 2. The middle one had a degree of 5, and then the other one had a degree of 2 because of that 1 plus 1. 5 was the highest, so it is a fifth degree trinomial. Fifth is quintic. So we're going to quickly make a chart here. If you don't have room, go ahead and pull out a piece of paper to do that. And then we're going to talk about the type of degrees we could have, because it's not really listed in this module at all. And while it's not required for this module, it could show up in other places. So degrees. If you have just a number, like the number 5, there's no variable with it, then we say, sorry. So again, if we have just a number, 5 in this case, it has a degree of 0 since there's no variable, and we call that a constant because it's always going to be 5. It's not going to change. If that 5 had a variable with it, with an exponent of 1, we say it has a degree of 1, and anything with a degree of 1 is linear. We've talked about a degree of 2. That's quadratic. And again, the most important one that you need to know. We then have a degree of 3, which we talked about, and that's cubic. Degree of 4 is quartic. Think of those quarters. Degree of 5, quintic. Quint, if you hear of somebody having quintuplets, that means they're having 5 babies. There's also a show on Disney called Quints, which was about 5 brothers and sisters. Anything above 5, you just call that number of degrees. So 6th degree, 7th degree, 8th degree, and so on. These are the only ones that have names. Just like in the polynomials, we have monomials, binomials, trinomials, and then it's just called polynomials after that. simplifying variable polynomials, we've actually already done that. It's simply combining like terms. Remember, like terms have to have two things. They have to have the same variable, and that variable has to have the same power or exponent. So in their example, they're showing you that r squared and 3r squared are like terms because they both have an r and an exponent of 2, but that 2r cubed, even though it has an r, is not a like term because it has a 3 instead of an exponent of 2. So you can combine the ones in blue, you cannot combine the one in red. So this would end up being 1r squared plus 3r squared, which is 4r squared. You only add exponents when multiplying. So since we're combining like terms, we're only changing the coefficient, the number in front. So this one would simplify to this. So in letter A, they make it, I think, to be honest, very confusing. So for example, I've got a 3r cubed here and a negative 4r cubed here. So I would go 3 minus 4, which is negative 1. And that's where they got this. Then the negative 2r squared is like terms with the 5r squared. Negative 2 plus 5 is where they got the positive 3r squared. They flip the order. Typically we write the number with the highest exponent first. We just wouldn't write the negative 1. We would just put negative r cubed plus 3r squared. And if you do flip it like they did, that's fine, but you don't need to. We're going to go ahead and just start some practice ones rather than look at theirs, because again, I'm not quite very happy with how they combine their like terms. I think it makes it harder. So let's move on. So 8 and 9. So let's go ahead and look at 8 together, and then you can do number 9. Well, the first thing I notice in number 8 is that all the way at the end, I can simplify 2 to the 5th, and that's actually 32. Now I'm going to start looking for like terms. I'm going to start with what I see first, which is 5r cubed. So I'm going to look for any other r cubes. I run into here, but make sure you take that minus sign with it because the sign in front of it tells you if it's positive or negative. So I have 5 minus 1r cubed, so that's 4r cubed. Then I look at the next one, which is a negative r squared s. You could put a 1 there if you wanted to. I have another r squared s. Negative 1 minus 3. Well, that's negative 4. And remember, we don't change exponents when adding or subtracting. We only change the coefficients. And then last but not least, I have a plus 6 and now a plus 32, which makes a positive 38. You could have written this in a different order and your answer would still be correct, as long as that 4r squared s is always negative or has a minus sign wherever you put it. Go ahead and try number 9, and then unpause the video when you're ready to check your answer. Alright, here we go. Again, there was something that you could simplify at the end. 5 cubed, that turns into 125. The first thing I run into is 7a squared. I look for any other a squareds, and there's 1 over here. So I have 7 plus 1, so that's 8a squared. Check your exponents, make sure you didn't change them. If it helped you out, you could also cross them out so you don't try to use them again. Then I have a negative ab, or negative 1ab, and a negative 5ab, so that's negative 6ab. And again, you could cross them out if that helped you out. And then I have just a number. I have a minus 75 and a plus 125. That should have given you plus 50. And now we have no more like terms, so this is my final answer. The last thing we're going to talk about is evaluating polynomials. Really and truly, you've done this skill already. It's just now sometimes we have more to evaluate or a longer problem. So really the only new part today was the very beginning with all that vocab. And we start using it so often it becomes pretty familiar to you. So here they give us an expression of negative 16t squared plus 200t plus 6, which gives us the height in feet of the firework. And they want to know how high the firework would rise if it has a 5-second fuse. Well, t represents the time, which is 5. So wherever there's a t, we're going to plug in a 5, which is what they did here. Now, order of operations would tell us to do the exponent part first, which is where they got the 25, and then we would start multiplying. So negative 16 times 25 was negative 400, 200 times 5 was 1,000, and then have that plus 6 from the formula. So add them all up together, it gives you 606. So this would raise 606 feet. We're going to ignore question 10 and keep on going for some more practice. So go ahead and try question 11 to wrap up today, and then unpause the video when you are ready to check. So here for this one, we're plugging in 4. So you should have negative 16 times 4 squared plus 200 times 4 plus 20. Order of operations would say exponents first. So I would now have negative 16 times 16. I'm going to go ahead and do the 200 times 4. You could wait, but I'm just going to go ahead and take care of it now, which is 800 plus 20. Negative 16 times 16 is negative 256. And when you add this all together, it was 564. So that's how tall it would rise on this platform. Well, let's talk about the question number 10 that we skipped for a second. If you'll look back, you'll see the first equation started with a 6-foot platform and it had a plus 6. Well, this one starts at a 20-foot high platform and it has a plus 20. Number 10 stated that it had a 100-foot platform, but there was a plus 200 in the equation, or in the expression. So would that expression work? And that is no, because that n number needs to represent where that platform is starting from.